Please subscribe our channel and also click on bell icons to get the latest video of our channel. Please inspire us by clicking on like icons. Also, if you have any doubt or query, feel free to share it in comment.
Okay guys, as we have learned about rational numbers and notation of these numbers is as p by q forms where q not equal to 0 and pq are integers. Okay, so rational numbers are written in the form. The definition of irrational numbers exists from the definition of rational numbers. What are irrational numbers? Irrational numbers are those numbers which cannot written in the form p by q not equal to 0 and pq integers. Cannot written, if written then rationals, and if cannot written then irrationals. So we can take example that as you know the pi which is written as 22 by 7. Okay, but this is rational because 22 and 7 are integers and 7 is not equal to 0, so it is written in this form. So this is rational number, but it is given in the example of irrationals. Why? Because pi is irrational, because this 22 by 7 is not exact value of pi. It is just estimated or approximate value. So irrational numbers are those numbers which are not rational. In our previous video, I have clearly discussed that when any fraction is converted into decimal expansion, then we can reach at a point where remainder is not 0, and there two cases arise: if remainder is repeated or remainder is not repeated. So non-terminating, non-repeating, okay, non-terminating, non-repeating non-terminating, non-repeating decimal expansions are said to be irrational numbers. So example can be taken as root 2, root 3, root 4 and like that are irrationals. Okay, so you can clearly identify which number is rational, which number is not rational, means irrational. So the irrational numbers can be defined easily that numbers which are not rational. Okay, I think you have clearly understand what I want to say. Now the question arises, how these irrational numbers can be represented on number line. Representation of irrational on number line. So okay, if you have any problem in identification of numbers from natural number up to irrational number, then you can put your query in comment box. Okay, now you can come to the representation of irrational numbers on the number line. As you know, number line, as you can easily see that on this number line, the complete number means natural number, whole number and integers are easily represented on this line, because 2 is complete number. So we are taking 2, 3, 4, -1, -2. You can see easily. But irrational numbers or fractional numbers, how these numbers how these numbers can be find the position of these numbers on this number line. So it is not as easy to find the position of irrational number on this number line as the integers, natural number or whole number. So we will learn how irrational numbers are represented on this line. Okay, we can take example of root 2, root 3, root 5, and so a lot of numbers can be taken, how these numbers are represented. So take first 3. First of all, we have to remember that Pythagoras theorem is the result which is generated from right angle triangle. This is hypotenuse, this is base, and this is perpendicular, and the result one is hypotenuse square equal to square of base plus square of perpendicular. Okay, this is the first point which is used. Now we will learn how to represent root 3 on number line. The first step is break root 3 in two values, that may be root 2 square and 1 square. We can take many values here, but we are just taking it because we want to find these 2 points. When we compare these values with these 2 points, so we will get the base and the perpendicular one. Okay, now in this part, this root 2 is again irrational number. So first we have to find position of root 2. How this root 2 can be break in this form, square of 1 plus square of another 1. Okay, now we will first represent root 2 on this line, and after finding the position of root 2, with the help of that position we will find the position of root 3 on this number line. Now take a line on which this is origin point, means 0, and we can take these positions as 1 unit, means each points have difference same, that equal to 1 unit. This difference is 1 unit, and in the same way its left side you can take values, but there is no need, as you know, because both of the values are positive. So we can take this value as base and this value as perpendicular. Why? The criteria of choosing this is that these two values may not be same in every question. These may be different, one is greater and one is smaller. So choose the greater value as the base. Okay, now here is both values same, so this one both may be base or perpendicular. We are taking base 1 means 1 unit, so this is our origin and this length is 1 unit. Okay, this distance of 1 unit can be taken as base. Now draw a perpendicular line, means 90-degree angle at this point 1. I am just taking on in a rough manner, but you can use your instruments. This angle is 90 degree, means this is vertical line. You can put name here as A, this point can be named as B, and this point can be named as C. Now the distance AB, what is distance AB? Here distance AB is 1 unit and this 1 unit. Okay, now another value is also 1 unit, and as we are keeping distance same, so here we also keep same distance, and this is 1 unit, means this is our C point. Okay, now you can draw hypotenuse in this right angle triangle. This is our hypotenuse. Stop. Okay, this is our hypotenuse. This is C point, or you can say C dash. In right angle triangle A, B, C dash, hypotenuse is AC dash. What is value of this AC dash? As AB is 1 unit, also BC dash is 1 unit. Okay, now using this formula we can find value of hypotenuse, that is AC dash, that would be square of AB plus BC dash, square of BC dash, means 1 plus 1. Okay, so this is root 2. Now you can use your protractor. A is your origin, and take distance as AC dash. As you can clearly see that I am taking distance AC dash, which is hypotenuse of this triangle. Now we will draw a semicircle and draw a semicircle. Semicircle taking radius this value. Okay, this semicircle can be drawn. As we see, this semicircle's circumference intersect this at the point you can take P. This P point is position of root 2 on this number line. I think you can easily understand that we have just find the position of root 2 on this number line, but we have taken example of root 3, and root 2 is just a part of this question. Okay, now we will draw root 3. In this root 3, as we are taking here root 2 and here root 1, this is greater value, this is smaller value, so the base can be taken as root 2. Now, as this is radius AC dash and this is also radius AP, so both are equal, means this value is root 2, so this value is also root 2. Now for the representation of root 3, we should take root 2 as base, and our base would be AC dash, or in another way we can take base as AP, but that would be another method. First we will take AC as base, that is root 2. Now our base would be root 2, and as in the process we have to take vertical line taking this base C dash as origin, and keeping distance again 1 unit. Why 1 unit? Because here also 1 unit value, this is 1 unit. This is right angle triangle, and we can give it name as D, and we can draw AD as we can draw AD as hypotenuse. So as you are seeing that space is very small left with us, we can use this space for this proceedings. Now we have right angle triangle AC dash D. Okay, and in this triangle AD square, which is hypotenuse, is equal to AC dash square, which is base, and C dash D square, which is perpendicular. Now you can easily see that what is AC dash? This is root 2. And what is C dash D? That is 1 unit. And so total would be root 3. Okay. Now again we will use this protector to withdraw semicircle, taking distance as hypotenuse, that is AD, on this number line. You can see we will write as okay. The position of root 3 would be this point. Give it name as P dash. Okay, so P dash is the position of root 3 on this number line. Again, we can see the alternative one for this representation, but the system would be near about same. First of all, we will draw root 2, means we will find the position of root 2 on number line, and then root 3. Now take this number line, again keeping distance 1 unit between each term. Keeping distance 1 unit between each term. This is 1, this is 2. Okay, distance would be same. This is 1, 2, 3, 4, 5 and so on. This is 0. Now first draw root 2. The method of drawing of root 2 is same as in the same as earlier, as we have drawn. Root 2 means square of 1 and square of another 1, and this point is A, this point is B, and we will take distance of 1 unit, that is C. Okay, now this is hypotenuse of this right angle triangle ABC. Now keeping distance this and draw, and the drawing of this semicircle can be done in this way, and the position of this point P. Okay, P is position of root 2 on this number line. That is the same. Now it is another way. What is in the sense of another way? We will take perpendicular line, vertical line, taking the P as origin. Okay, and I think using this we can find it, the position here, and the vertical line will be in this way. Now this is right angle, this is a right angle, and as we have seen that root 3 can be broken in two values, that is root 2 and 1. Now our base is this AP. Here AP is root 2. This is root 2, that is root 2 AP, and our second value is 1, so take on this line as distance 1 unit, 1 unit, that would be here, and we can give this point as any name D. Okay, now it is our origin, and in this may be our hypotenuse. In right angle triangle APD, okay, APD, here AP is root 2 and PD is equal to 1 unit. Now taking this as radius, draw. Now taking AD as radius, draw a semicircle in this way, and we will get this point as P dash. Okay, AD is equal to root 3, and as AD is equal to AP dash, because both are radius, both are radius. Okay, so it can easily seen that P dash is position of root 3 on this number line. This is another method. So not a much difference. We can draw a triangle in this way, or we can draw a triangle in this way. We will find the position of irrational numbers. So not a very difficult one, but we have keep in our mind that this must be radius, and because of radius of any circles are same, so this length and this length would be same, and so this P dash point is a representation of a P dash. Now can I give you exercise? So please try root 4 and root 6, root 4 and root 6 to find position on number line. If you will find any problem in this representation, then you can ask me question, or you can put your query in comment box of this video. Okay, now come to the exercise 1.2 of 9th class of NCERT mathematics. Question number first: state whether the following statements are true or false. Justify your answer. The first question is that every rational number is a real number. Every irrational number is a real number. As in previous video, I have already told you that any number you can think about is a real number. You can see in your surrounding, that is real number. So real numbers are made from these two rationals and irrationals. So all rationals are real number, all irrationals are real number. So first question is you can say true, because every irrational number is also a real number. So first part is yes, true. Why true? Because every irrational is a real number. Second part, every point on the number line is of the form under root m, where m is natural number. Every point on the number line is of the form root m. Is it true? I think no, because on the number line, as you see, this is number line 0, 1, 2 and so on, and this may be root 2, so every number is not of the form under root m, means not of the form irrational one. This number line also have points like 0, 1, 2, that is irrational, that is natural number, that is rational number, that is integers. So not all the numbers of the form irrational. Okay, now come to the third question. Every real number is an irrational number. Every real number is irrational number. That is not possible. Why? Because real number is combined number of rational and irrational, and in our definition I have clearly told you that irrational numbers are not rationals and rational numbers are not irrationals. So every real is not only irrationals, it contains rationals also. Okay, so every real number is not irrational numbers. That is part of rational number also. So false. Now come to the question number 2. Are the square root of all positive integers irrational? Are the square root of all positive integer irrational? Positive integer can be take positive integer. Take positive integer as 9. Okay. Now take positive integer 9. Now root 9 is equal to 3. So the question is, are the square root of all positive integer irrational? No, this is rational number. What is this? Is rational, not irrational. If not, give an example of the square root of a number that is rational number. So the question is complete. Now question number 3. Show how root 5 can be represented on the number line. Root 5. Easy, very easy, because we can make partial numbers of it as square of 2 and square of 1. So easy. Here this is greater value, this is smaller value. I will use free hand to make representation, because we have discussed in our earlier. Now this is origin, this is 1, this is 2, this is 3, keeping distance 1 unit, that is equal. And now take 2 units. 2 units means this and this. So this can be named as A and this can be named as B. Now take this distance and a perpendicular line as C, and that is also 1 unit, and this is our hypotenuse. So in right angle triangle ABC, in right angle triangle ABC, we take AB equal to 2 and BC equal to 1 and AC equal to root 5. Okay, now keeping this distance as radius, draw a semicircle, keeping this distance, draw a semicircle in this way. So position of this is P, and we can say that P is required position. Required position of root 5. Okay. Now question number 4, classroom activity. You have to construct a spiral of square roots, and that is not a tough one. You can do it very easily, and you can take it as your activity, and this may be your exercise complete. If you have any query in any question, in any problem, at any point, you can put your query in comment box, and I will try to solve that query as soon as possible. So thanks.